appraisals of the value of a necklace are uniformly distributed on theta minus 3 to theta plus 1, where theta is the actual price the owner paid for the necklace. 4 mutually independent appraisals are obtained. Let L denote the lowest of the 4 appraisals and H the highest of the 4. Calculate the probability that the actual price is between the lowest appraisal and the highest appraisal. So let N be the number of appraisals, and let us call an appraisal being less than the price is a success. So an appraisal is either less than the price or it's greater than or equal to the price. So it's a binomial distribution. N has a binomial distribution. N is 4 because there are 4 appraisals. And let Y be the amount of appraisal which is given to be uniformly distributed on theta minus 3 to theta plus 1. So as we said, N is binomial, and with little n equals to 4 trials, 4 appraisals. And we need to find the probability of success on each appraisal, on each trial. And we are calling the success as the appraisal being less than the actual price. So if we call Y to be the appraisal, then the success is the probability Y is less than theta, because remember theta was the actual price and Y was the appraisal price. And so Y is uniformly distributed on theta minus 3 to theta plus 1. So the probability Y less than theta. So when you are less than theta on this interval, then that means you are between theta minus 3 and theta. So the difference is theta minus 3 and divided by the total interval distance, just theta plus 1 minus theta minus 3. And we get 3 on the top and we get 4 in the bottom. So that's 3/5. So 0.75 is the probability of success in each trial. And we need probability theta is between L and H. So remember, theta was the actual price, L was the lowest appraisal, H the highest appraisal. There are 4 appraisals total. And so this is actually the probability that the lowest of the 4 appraisals, which would be L, is below the actual price. Remember, actual price is theta. And the highest appraisal, which is H, is greater than the actual price. So this can happen, for example, when exactly 1 appraisal is below the actual price. So if exactly 1 appraisal is below the actual price, so then that will be the lowest appraisal, and then the other 3 are greater than the actual price. And it can also happen when exactly 2 appraisals are below the actual price, because then also there will be one which will be higher than the actual price. And remember, price is a continuous variable, so here we don't have to worry about the equality being there or not. And even when 3 appraisals are below the actual price, then the lowest of them will obviously be below the actual price. And then since we are saying that 3 appraisals are below the actual price, so there will still be one which will be above the actual price. So that means the highest in this case will still be above the actual price. So these are the 3 situations. When exactly 1, 2, or 3 appraisals are below the actual price, then we are guaranteed that the lowest appraisal will be below the actual price and the highest will be above the actual price. Because remember, the only other options besides the 1, 2, 3 are 0 and 4, because remember there are a total of 4 appraisals. So there could be 0, 1, 2, 3, or 4 appraisals that are below the actual price. Now, if none of them are below the actual price, it means all of them are above the actual price, and then that means the lowest appraisal will not be less than the actual price. Similarly, if all 4 are below the actual price, then there will be none which is higher than the actual price, and then the highest appraisal will not be higher than the actual price. So 1, 2, and 3 appraisals being below the actual price will result in this situation that the actual price is greater than the lowest and less than the highest appraisal. So in other words, what we need is we need the binomial probability where with successes 1, 2, or 3. So the binomial formula is fx equals 4 combination x, because n is 4 in this case, and then little p was 0.75, so 0.75 power x, and then 1 minus p would be 0.25, 0.25 power 4 minus x. And as we said, we want probability x equals 1, 2, or 3, which means f1 plus f2 plus f3. And then we just substitute x equals 1, 2, and 3 in this formula, and we end up getting 0.680, which is choice D.